thinking distance, right? So we need to identify thinking distance can only be cannot be affected by the condition of the road. Condition of the road actually affects the braking distance. Which of these will increase the braking distance of the car? Faster reaction time, that is going to affect the thinking distance. Ice on the road is going to actually increase the braking distance. Powerful brakes will decrease the braking distance. So the correct answer is this one. We know that this affects the thinking distance. More powerful brakes will reduce or decrease the braking distance. And tires which have a good grip will provide enough friction. So in that way, they are going to decrease the braking distance. Determine the stopping distance of the car when the speed of the car is 20 meters per second. So stopping distance is actually thinking distance or braking distance plus the thinking distance in that case. So we are going to go straight. Let me just reduce this a little bit. We are going to go straight to the graph, and then we try to identify at 20 meters per second. We read the thinking distance and also braking distance. We read this ones, this point here. Okay, let me just write it. We read this particular point here, and also at this point here is 27. So 27 is the braking distance and the 10 is the thinking distance. So for us to get the stopping distance, we're going to add the two distances together, and that's going to translate to 37 meters. State the formula linking average speed, distance moved, average speed, distance moved, and time taken. We can say average speed equals to distance moved divided by the time taken. Determine the reaction time for the driver. So we're going to make T the subject of the formula and then substitute into the formula in order to get that. So reaction time, there's 15 here, and we need also to check the so if you work it out, you are going to have our answer 0.5 seconds. Calculate the mean braking acceleration. Acceleration is obtained from a velocity time graph. Acceleration is actually obtained from a slope, but in this case we need to look at a different aspect to use. How do we get acceleration? We are going to use the equations of motion, because to work out the mean acceleration of the car and to when it stops. So we have the final speed, we have the initial speed, and we can be able to get the distance. So we can be able to use this formula, yes, but I would rather, let me see, let us see what we can do here. We shall use the equations of motion. That is S is our braking distance. S is the displacement. Yes, S is the displacement. S is the displacement. U is the initial velocity. V is the final velocity. So V is final because this car is coming to a complete stop. So we can be able to use the formula V squared equals to U squared plus 2AS. And then if we substitute everything that we have into this, so what are we going to do here? We're going to say this going to be yes, we substitute what we have. What is it going to be? Just using our calculators, we're going to get negative 8.65 meter per second square. And since this is a deceleration, all right, moving to the a hint. It's not going to be a straight line graph here because you are told draw a curve of best fit. So point that we have here, and you can see the height is 0. Going to have this as this moment. If